IPv6 dynamic address assignment. In this video, I'm going to talk about how we can dynamically assign IPv6 addresses to, for example, one interface. But in this video, we should focus on the stateless address auto configuration, or SLAAC. Okay, let me to start talking about for example, the dynamic address assignment in IPv6. You know that in IPv4, only we can use DHCP service or dynamic host configuration protocol for dynamic address assignment. In IPv6, we can use multiple methods for dynamic IPv6 address assignment. The first method is using the stateless address auto configuration, the topic that I want to talk about that in this video. And the second method is the stateless DHCP, and the third method is stateful DHCP. Stateful DHCP. These are the methods of the dynamic IPv6 address assignment, and as you can see, we have three methods of dynamic address assignment in IPv6 in compare of IPv4 that only we have one method, and that is the DHCP. In this scenario, in this video, I want to talk about the first method, stateless address auto configuration. Stateless address auto configuration. And as you know, we don't have any counterpart for these methods in the IPv4. But how we can use a stateless address auto configuration, and what is the stateless address auto configuration? Look at here. You know that in IPv6 we can use routers for routing. For example, as you saw in the previous video, when we configured IPv6 unicast routing, okay, on this router changed its capability from a host to a router. Okay, now we have a router, and this means that router now can, for example, forward IPv6 packets from one interface to another interface. Okay, this is the normal function of a router, and you understand how router can forward the packet with checking the destination IPv6 of packet with the routing table, and I will talk about this feature in the future videos in the routing part of this class. Very good. But for now, I want to talk about a stateless address auto configuration, or SLAAC. The first thing that I want to say is that when a router, when a router in IPv6 has this command, this router periodically should send a special message on this interface, for example, the ETH00 or other interfaces, that we configured IPv6 on it. The router should advertise a special message on this interface. We call it RA. What is the RA? RA is the abbreviation of the router advertisement. Router advertisement should be sent periodically, and by default the period of sending the RA is 200 seconds. You can change it, but by default every 200 seconds an RA should be sent on this interface. RA should be sent to the all IPv6 enabled hosts IPv6 address FF02:1, and the source IP of the RA is the LLA address, link local address of the interface of router. RA should receive with all hosts that reside on this network. Why? Because the destination IP of the RA is FF02:1, and this means that every PC that has TCP IPv6 and TCP IPv6 is enabled on it should receive this packet, because you know that every system that has TCP IPv6 has this IP address enabled on its interfaces. Okay, because of that, RA should accept it or should receive with the PC1, PC2, PC3 and other PCs or hosts that have this TCP IPv6. The next question is that what is the RA's information? Okay, look at here. RA has many information. I will talk about that information in, for example, some videos. But for now, the important things that I want to say is that RA contains the prefix of this network. For example, if you configure the ETH00 with this IP address 2001 db811:1/64, the RA contains the prefix of this network. The prefix of this networks or the subnet prefix of this interface is 2001 db8 then 1:64. This is the subnet prefix of these networks. And because of that, every PC when received the RA message, every PC now can learn the prefix of this network. Because of that, R1 knows the prefix of this network's 2001 db811:/64 and also PC2 and also PC3. And because all of these PCs, all of these hosts now have the, for example, the prefix of these networks, they can use the EUI64 or random method. This is based on the operating system that reside in the PCs, that installed in the PCs, but they can use, for example, EUI64 or random method to generate its IPv6 address without using the DHCP. Look at here. Our router should give the RA, and the destination of RA is all IPv6 enabled interfaces. Because of that, every host should accept this RA message, and in RA message we have a prefix. The prefix of these networks, the prefix of interface of router. Because of that, now PC1, PC2, PC3 should receive and has the, for example, the prefix of the network. They can use this prefix and combine it with the EUI64 to create their unique IPv6 address of the PC1. You know that this IPv6 address is unique. Why? Because it's created from the EUI64 or random method. Because of that, every PC now has, for example, its unique IPv6 address without using the DHCP and without manual configuration. So interesting. This is the new method that we can use it in the IPv6. And also in this RA message, router should send its for example, link local address. And this link local address, this is the link local of router interface. Okay, this means that every PC now have this LLA, and it can use this LLA address for its default gateway. Now every PC has generated its IPv6 address and also has received its default gateway. And because of that, every PC now can communicate with inside of the network and also outside of the network, or outside of its network. So interesting. Without using any DHCP, every PC now has basics or fundamentals addressing, means IPv6 address and also default gateway address. And this is so interesting because I didn't enable any service. For example, I didn't enable the DHCP or some other services. This is the stateless address auto configuration or auto configuration. Maybe you ask me, what is the stateless address? Why we are using a stateless address? Because this address generated by PCs and nobody has the state of the IP address of the PCs. For example, if you use DHCP gives you an IP address and saves your state, for example, MAC address, for example, which system receives this